अस्सलाम वालेकुम फोर्थ। आज हम पढ़ें सेमी कंडक्टर। सेमी कंडक्टर जैसे कि हम पीछे चैप्टर में पढ़ चुके हैं कि हमारे पास वो होते हैं कंडक्टर, इंसुलेटर्स और सेमी कंडक्टर। सेमी कंडक्टर जो है वो नेदर गुड कंडक्टर नॉर इंसुलेटर फॉर द इलेक्ट्रिक करंट, और सेमी कंडक्टर हैव इंटरमीडिएट वैल्यू ऑफ रेजिस्टिविटी। इन सेमी कंडक्टर्स द नंबर ऑफ इलेक्ट्रॉन इन द outermost shell is 4 प्रेजेंट इन द outermost shell। जनरली जो हमारे पास सेमीकंडक्टर वो यूज हुआ सिलिकॉन और जर्मेनियम। atomic number of silicon is 14, number of electron in the first orbit 2, or in the second orbit 8, and the third orbit 4, which is the outermost orbit of silicon. Similarly, number of electron in the outermost orbit of germanium 4. Each germanium is surrounded by 4 equidistant atoms to complete the outermost orbit. Germanium atoms share with the electron of each of the 4 neighboring atoms. In this way, a bond is produced between the germanium atom. Such bond in which electrons are shared is called the covalent bond. Covalent bond. जो semiconductor is absolute zero temperature, have all the charge bond to the atom and behave like an insulator. When the temperature of the increase, some covalent bonds are broken and free electrons are available, so the electron is small current is possible. Experiments showed that the conductivity of poor germanium crystal increase with the rise of the temperature. When the light is allowed to fall on the poor germanium crystal, it is observed with a few atomic layers. The observed energy enough to break the covalent bond, and so free electrons and holes are created. This process is called the photoionization. The conductivity of crystal also increase in the absence of presence of light. This response is to light is called photoconductivity. These are the basic characteristics of the semiconductor. There are two types of semiconductor: N type semiconductor or P type semiconductor. When a pentavalent impurity like Sb, the outermost shell have 5 electrons if added to a germanium. Sp antimony, which have outermost shell have 5 electron if added to a germanium. 4 electron will make with the germanium covalent bond. Only 1 electron will be remain free. This is known as a free electron. Or germanium or silicon crystal formed after ending the pentavalent impurity. There is a excess of electron, and there are free electrons, so they are conduct the electricity. That's why it is called the N-type semiconductor. In N-type semiconductor, electrons are donate or majority charge carriers, or holes are the minority charge carriers. The impurity with 5 electron is called the donor because it provides a free electron. This is the N-type. The diagram is shown in 1.14 N-type crystal lattice. There are 4 covalent bonds with the antimony or germanium, and 1 is the free electron, and free electron conduct the electricity. Another is pentavalent. When a trivalent like if added in a germanium crystal, 3 valence electron of each trivalent atom form a covalent bond with the 3 atoms of germanium, and there exists a vacancy of for electron in the fourth covalent bond, where covalent bond such as aluminum. Aluminum have is a trivalent impurity, or when it doped with the germanium, then there are three electron make the covalent bond. One electron, there is a hole, a pair have a one hole. A crystal of germanium or silicon after adding trivalent impurity is called a p-type. Sometimes holes are vacant space in which electron can easily move under the influence of the applied electric field, or hole is a positive charge outside the nucleus, present only in a semiconductor because of unfilled covalent bond. A hole has a some amount of positive charge as that of a proton equal to that of a electron. However, hole is not a proton. Hole is not a proton, only positive charge. In p-type, majority charge carriers are holes, and minority charge carriers are electrons. So this is known as the p-type semiconductor. The doping, what is doping? The process of introducing an impurity to semiconductor is called doping. Impurity such as germanium and silicon, and the outermost shell of 4 electron, when they add to a trivalent or pentavalent atom, then this process is called the doping. Or intrinsic semiconductor or extrinsic semiconductor. Intrinsic semiconductor is one which is made up of the semiconductor material in its extremely pure form, such as the common example of such material is germanium and silicon, which have forbidden gap of 0.72 electron volt, 1.1 electron volt respectively. Or extrinsic semiconductor, those instinctive semiconductor to which some suitable impurity or doping agent has been added, such as in p-type or n-type we add the trivalent or pentavalent impurity in the germanium, then this is known as the extrinsic semiconductor, or impurity is called a extrinsic semiconductor. Depending upon the type of the doping material, type in type में n type semiconductor और p type semiconductor. अब इन n type हमारे पास क्या होगा? There are number of free electrons, or they conduct electricity. Or in the p type semiconductor, there is excess of hole, and electrons from the outermost shell, the other atom are filled this hole. Thank you.